Is there some interesting like challenges to you guys a pretty new startup to get scaling to so many people and
Yeah, I think that it has been an interesting journey, adding, each extra zero to the request per second. You run into all of these with like the general components you're using for caching and databases run into issues as you make things bigger and bigger. And now we're at the scale where we get like, int overflows on our tables and things like that. And then also there have been some custom systems that we've built, like for instance, our retrieval system for computing a semantic index of your codebase and answering questions about a codebase that have continually, I feel like, been one of the trickier things to scale.
I have a few friends who are super senior engineers, and one of their sort of lines is like it's very hard to predict where systems will break when you scale them. You can sort of try to predict in advance, but like there's always something weird that's going to happen when you add this extra zero, and you thought through everything, but you didn't actually think through everything. But I think for that particular system, so what the for concrete details, the thing we do is obviously we upload when like we chunk up all of your code, and then we send up sort of the code for embedding, and we embed the code, and then we store the embeddings in a database, but we don't actually store any of the code. And then there's reasons around making sure that we don't introduce client bugs, because we're very, very paranoid about client bugs. We store much of the details on the server, like everything is sort of encrypted. So one of the technical challenges is always making sure that the local index, the local codebase state, is the same as the state that is on the server. And the way sort of technically we ended up doing that is, so for every single file, you can sort of keep this hash, and then for every folder, you can sort of keep a hash, which is sort of the hash of all of its children, and you can sort of recursively do that until the top. And why do something complicated? One thing you could do is you could keep a hash for every file. Then every minute you could try to download the hashes that are on the server, figure out what are the files that don't exist on the server. Maybe you just created a new file. Maybe you just deleted a file. Maybe you checked out a new branch, and try to reconcile the state between the client and the server. But that introduces like absolutely ginormous network overhead, both on the client side. I mean, nobody really wants us to hammer their Wi-Fi all the time if you're using Cursor. But also, like, I mean, it would introduce like ginormous overhead on the database. I mean, it would sort of be reading this tens of terabyte database, sort of approaching like 20 terabytes or something database like every second. That's just sort of kind of crazy. You definitely don't want to do that. So what you do, you just try to reconcile the single hash, which is at the root of the project. And then if something mismatches, then you find where all the things disagree. Maybe you look at the children and see if the hashes match, and if the hashes don't match, go look at their children, and so on. But you only do that in the scenario where things don't match. And for most people, most of the time, the hashes match.
So it's a kind of like hierarchical reconciliation.
Yeah, something like that.
Yeah, it's called a Merkle tree.
Yeah. Merkle. Yeah. I mean, so yeah, it's just cool to see that you kind of have to think through all these problems.
And I mean, the point of like the reason it's gotten hard is just because, like, the number of people using it, and if some of your customers have really, really large code bases, to the point where we originally wrote our code base, which is big, but I mean, it's just not the size of some company that's been there for 20 years and sort of has a ginormous number of files, and you sort of want to scale that across programmers. There's all these details where like building the simple thing is easy, but sort of scaling it to a lot of people, like a lot of companies, is obviously a difficult problem, which is sort of independent of actually. So there's part of this scaling our current solution is also coming up with new ideas that obviously we're working on, but then scaling all of that in the last few months.
Yeah, and there are a lot of clever things, like additional things that go into this indexing system. For example, the bottleneck in terms of costs is not storing things in the vector database or the database. It's actually embedding the code. And you don't want to re-embed the code base for every single person in a company that is using the same exact code, except for maybe they're in a different branch with a few different files, or they've made a few local changes. And so because, again, embeddings are the bottleneck, you can do this one clever trick and not have to worry about like the complexity of like dealing with branches and the other databases where you just have some cache on the actual vectors computed from the hash of a given chunk.
Mm-hmm.
And so this means that when the nth person at a company goes and embeds their code base, it's really, really fast. And you do all this without actually storing any code on our servers at all. No code data is stored. We just store the vectors in the vector database and the vector cache.
What's the biggest gains at this time you get from indexing the code base? Like, just out of curiosity, like what benefit do users have? It seems like longer term there'll be more and more benefit, but in the short term, just asking questions of the code base, what's the usefulness of that?
I think the most obvious one is just you want to find out where something is happening in your large code base. And you sort of have a fuzzy memory of, okay, I want to find the place where we do X. But you don't exactly know what to search for in a normal text search. And so you ask a chat, you hit Command Enter to ask with the codebase chat, and then very often it finds the right place that you were thinking of.
I think, like you mentioned, in the future, I think this is only going to get more and more powerful, where we're working a lot on improving the quality of our retrieval. And I think the ceiling for that is really, really much higher than people give it credit for.
One question that's good to ask here: have you considered, and why haven't you much done sort of local stuff to where you can do it seems like everything we just discussed is exceptionally difficult to do. To go to the cloud, you have to think about all these things with the caching and the large code bases with a large number of programmers are using the same code base. You have to figure out the puzzle of that. A lot of it, most software just does this heavy computational stuff locally. So have you considered doing sort of embeddings locally?
Yeah, we thought about it, and I think it would be cool to do it locally. I think it's just really hard. And one thing to keep in mind is that, some of our users use the latest MacBook Pro, but most of our users, like more than 80% of our users, are in Windows machines, which and many of them are not very powerful. And so local models really only works on the latest computers, and it's also a big overhead to build that in. And so even if we would like to do that, it's currently not something that we are able to focus on. And I think there are some people that do that, and I think that's great. But especially as models get bigger and bigger, and you want to do fancier things with like bigger models, it becomes even harder to do it locally.
Yeah.
And it's not a problem of like weaker computers. It's just that, for example, if you're some big company, you have big company code base, it's just really hard to process big company code base even on the beefiest MacBook Pros.
Yeah.
So even if it's not even a matter of like if you're just like a student or something, I think if you're like the best programmer at a big company, you're still going to have a horrible experience if you do everything locally. I mean, you could do it and sort of scrape by, but like again, it wouldn't be fun anymore.
Yeah, like at approximate nearest neighbors, and this massive code base is going to just eat up your memory and your CPU. And so it's best to offload that. And that's just that. Like, let's talk about like also the modeling side, where, as Arvid said, there are these massive headwinds against local models, where one, things that seem to move towards MOEs, which like one benefit is maybe they're more memory bandwidth bound, which plays in favor of local versus using GPUs or using NVIDIA GPUs. But the downside is these models are just bigger in total, and they're going to need to fit often not even on a single node but multiple nodes. There's no way that's going to fit inside of even really good MacBooks. And I think especially for coding, it's not a question as much of like, does it clear some bar of like the model's good enough to do these things, and then like we're satisfied, which may be the case for other problems, and maybe where local models shine. But people are always going to want the best, the most intelligent, the most capable things, and that's going to be really, really hard to run for almost all people locally.
Don't you want the most capable model? Like you want Sonnet,
and also with O1.
I like how you're pitching me.
Like O1.
Would you be satisfied with an inferior model? I'm one of those, but there's some people that like to do stuff locally, especially like that really. There's a whole obviously open source movement that kind of resists, and it's good that they exist actually, because you want to resist the power centers that are
Yeah.
growing our.
There's actually an alternative to local models that I am particularly fond of. I think it's still very much in the research stage, but you could imagine to do homomorphic encryption for language model inference. So you encrypt your input on your local machine, then you send that up, and then the server can use loss of computation. They can run models that you cannot run locally on this encrypted data, but they cannot see what the data is. And then they send back the answer, and you decrypt the answer, and only you can see the answer. So I think that's still very much research, and all of it is about trying to make the overhead lower, because right now the overhead is really big. But if you can make that happen, I think that would be really, really cool. And I think it would be really, really impactful. Because I think one thing that's actually kind of worrisome is that as these models get better and better, they're going to become more and more economically useful. And so more and more of the world's information and data will flow through, one or two centralized actors. And then there are worries about, there can be traditional hacker attempts, but it also creates this kind of scary part where if all of the world's information is flowing through one node in plain text, you can have surveillance in very bad ways. And sometimes that will happen for, initially will be like good reasons, like people will want to try to protect against like bad actors using AI models in bad ways. And then you will add in some surveillance code, and then someone else will come in and, you're on a slippery slope, and then you start doing bad things with a lot of the world's data. And so I'm very hopeful that we can solve homomorphic encryption for language model
doing
inference.
privacy preserving machine learning. But I would say like that's the challenge we have with all software these days. It's like there's so many features that can be provided from the cloud, and all of us increasingly rely on it and make our life awesome. But there's downsides, and that's why you rely on really good security to protect from basic attacks.
Yeah.
But there's also only a small set of companies that are controlling that data, and they obviously have leverage, and they could be infiltrated in all kinds of ways. That's the world we live in.
I mean, the thing I'm just actually quite worried about is sort of the world where, so Anthropic has this responsible scaling policy, and sort of where we're on like the low ASLs, which is the Anthropic security level or whatever, of the models. But as we get to like quote unquote ASL3, ASL4, whatever models, which are sort of very powerful, both for mostly reasonable security reasons, you would want to monitor all the prompts. But I think that's sort of reasonable and understandable where everyone is coming from. But man, it'd be really horrible if sort of like all the world's information is sort of monitored that heavily. It's way too centralized. It's like sort of this, it's like really fine line you're walking where on the one side, like you don't want the models to go rogue. On the other side, like, man, it's humans, like I don't know if I trust like all the world's information to pass through like three model providers.
Yeah.
Why do you think it's different than cloud providers?
Because I think a lot of this data would never have gone to the cloud providers in the first place. Where this is often like you want to give more data to the AI models. You want to give personal data that you would never have put online in the first place to these companies or to these models. And it also centralizes control, where right now for cloud, you can often use your own encryption keys, and it like AWS can't really do much. But here is just centralized actors that see the exact plain text of everything.